Welcome back students. Good evening to all of you. This one is the lecture number 8. Okay. In this particular lecture we will discuss about the lens makers formula, also about the linear magnification produced by the lens, power of lens, and the another concept which is combination of thin lenses in contact. Okay, so this is also a very important topic related to the lens. Many times this question has been asked in your board exams. Okay, so lens makers formula. Here we have one convex lens. Okay, and as we know that lens has two spherical surfaces. Okay, two spherical surfaces. So here we have one object, point object at O, okay, is in the rare medium. Okay, this is your medium 1 and this is your medium, another medium 2. Okay, first reflecting surface and another refracting surface. Okay, this will be your point object at a distance of u from the optical center. When the ray incident on the first reflecting surface, it bends away, bends towards the normal. This will be your normal. Okay, एक्चुअल में इसे ये पथ फॉलो करते हुए पास होना चाहिए था, बट इट विल लिटिल बिट बैंड टूवर्ड्स द नॉर्मल. ओके, सो if I extend this way behind, okay, so this O dash will be your image of this point object. Okay, and after that this image O dash will behave as the object for the second spherical surface whose final image is at this point, that is I. Okay, so object O is in rare medium having refractive index of n1. The incident ray OQ is refracted at surface 1. The image is formed at O dash. Okay, so object distance is u and image distance is v. So we have the equation for the refraction through the spherical curved surface. You know very well about this equation. Okay, very familiar equation which we have discussed in the last class about spherical last lecture number 6. Okay, so when rays traveling from rare to denser medium, this equation is n minus n1 upon u plus n2 upon v equals to n2 minus n1 upon r. So u is what? U is u, but v is your v1. n2 minus n1 upon, say the radius of curvature of the first refracting surface will be r1. Okay, so this will be your equation number 1. When the rays traveling from denser to rarer medium after refraction through the first spherical surface, now rays traveling from through the second spherical surface towards the rare medium. Okay, so the object distance is v1 and image distance is v. So our formula becomes minus n2 upon u plus n1 upon v equals to n1 minus n2 upon r. So by putting the value of u and v, minus n2 upon v1 plus n1 upon v equals to n1 minus n2 upon r. By adding these two equation number 1 and equation number 2, we have this minus n1 upon u plus n2 upon v1 minus n2 upon v1 plus n1 upon v equals to n2 minus n1 upon r1 plus n1 minus n2 upon r2. Okay, or by taking n1 as a common, n1 1 upon v minus 1 upon u equals to n2 minus n1 upon r1 minus n2 minus n1 upon r2. Okay, okay, by shuffling this equation we can write n1 into 1 upon v minus 1 upon u equals to n2 minus n1, 1 upon r1 minus 1 upon r2. This n1 becomes denominator of this n2 minus n1, so 1 upon v minus 1 upon u equals to n2 minus n1 into 1 upon r1 minus 1 upon r2. This is called the Lensmaker's formula. N1 is the refractive index of air, that is always 1, and N2 can be find out by the this formula. Okay, if object is at infinity, so image is at focus. At this condition, the distance of an image is equals to the focal length. Okay, so our equation becomes what? 1 upon f minus 1 upon infinity equals to n2 minus n1 upon n1, 1 upon r1 minus 1 upon r2. So 1 upon f equals to n2 minus n1 upon n1 and 1 upon r1 minus 1 upon r2. Okay, on comparing equation number 4, this will be your equation number 3 and this will be your equation number 4. On comparing 3 and 4, we get 1 upon f equals to 1 upon v minus 1 upon u. Okay, on further shuffling this particular equation, 1 upon f, equation number 3, on shuffling equation number 3, 1 upon f equals to n2 upon n1 minus n1 upon n1, 1 upon r1 minus 1 upon r2, or 1 upon f equals to n2 upon n1 minus 1 into 1 upon r1 minus 1 upon r2. This n2 minus n1 can be say mu equals to n2 upon n1, called the refractive index. Okay, so 1 upon f equals to mu minus 1 into 1 upon r1 minus 1 upon r2. Okay, so this is the final equation.